Hey seniors, today we're going to work on converting repeating decimals to fractions. So let's jump right in. On your notes page, go ahead and draw your line and then write converting repeating decimals to fractions in the left-hand corner. I don't want you to take any notes for this slide, I just want you to pay attention. This is a pretty complex process, but it's super simple once we break it down. Alright, so if I want to change 0.4 to a fraction, there are 5 steps I go through. And again, I know that this is a repeating decimal because I see the line on top of the number. So my first step is to set x equal to the repeating value. So let's go ahead and do that. X equals 0.4. Identify which digits are repeating. Well, I know the 4 is repeating. Multiply both sides so that the repeating digits are to the left of the decimal. You'll recall from scientific notation, if I want to move a decimal, I have to multiply by 10, which in scientific notation would be the equivalent of adding an exponent. We don't have exponents here, so all we have to do is multiply both sides by 10 to move my decimal. All right, so that brings us out to 10x equals 4.4, because again, I move my decimal to the left. All right, my next step is to subtract the original equation, which was x equals 0.4, from the new equation. So let's go ahead and do that. Remember, x equals 0.4 was my original equation. Then all I do is subtract down. 10x minus x equals 9x. 4.4 minus 0.4 just leaves me with 4, because 4 minus 4 is 0, 4 minus 0 is 4. So I'm left with 9x equals 4. It's really simple algebra at this point. All we have to do is solve for x. So I'm going to divide both sides by 9, and that leaves me with 4 ninths. And that is my fraction for the repeating decimal. And I know that this can't be simplified down any further, so that's my final answer. Let's do another one. All right, 0.3. My first step, I do want you to write this down, so my pen is your pen. 0.3, I know it's repeating because of the line at the top, so my first step is to set x equal to 0.3. My next step is I need to move my decimal one space to the right in order to have create my new equation. So the way I do that is I multiply both sides by 10. And that brings me to 10x equals 3.3. Then I just take my original equation and I subtract down. 10x minus x is 9x. 3 minus 3 is 0. 3 minus 0 is 3. My last step is just to solve for x. So I have 9x equals 3. I'm going to divide by 9 on both sides, and that's going to leave me with x equals 3 ninths. This would be my final answer, except that I see that this fraction can be simplified. If I divide the top and bottom by 3, I come out with 1/3. All right, let's do another one. All right, let's do 0.8 as repeating. All right, my first step is to set x equal to 0.8. I know that I have to get my second equation to have a number to the right of the decimal, so I go ahead and multiply both sides by 10. That leaves me with 10x equals 8.8. And then I just have to subtract out my original equation. So if I subtract down, 10x minus x equals 9x. 8 minus 0 is 8. 8 minus 8 is 0. So I'm left with 9x equals 8. And all I have to do now is solve for x. Divide by 9 on both sides. X equals 8 ninths. So that is my fraction for the repeating decimal, 0.88888. And that's the process we're going to go through every single time on repeating decimals. All right, but if I wanted to convert a repeating decimal, convert a fraction to a decimal, I go through the same process as Monday. So I already know that 1/3 is a repeating decimal. It's the most famous repeating decimal ever. But I go through the same process. If I want to turn it to a decimal, top in, bottom out. Divide out my numbers. Top goes in, bottom goes out. 3 does not go into 1, so I go ahead and put a 0. Then I know I have a decimal here that I can bring up. And then 3 still doesn't go into 1, so I know I can add a 0. 3 does go into 10 3 times. 3 times 3 is 9. If I subtract down, 10 minus 9 is 1. 3 does not go into 1, so I got to bring down a 0. 3 does go into 10 3 times. 3 times 3 is 9. 10 minus 9 is 1. 3 still doesn't go into 1, so I add a 0. 3 does go into 10 3 times. 3 times 3 is 9. Hopefully you guys are seeing I could do this forever, and it would never end, because I know that 1/3 is a repeating decimal. So I can just represent my answer as 0.3 with our little bar at the top to show that it's a repeating decimal. And that's it. All right, guys, that's enough of me talking. Let's get you guys practicing.